Good morning, good afternoon, good evening. This is Mr. Payne bringing you linear versus exponential. Unit 6, Lesson 8. Linear and exponential functions share many characteristics. This is because they are based on two different but similar sets of principles. Linear functions are based on repeatedly adding the same amount, the slope. Exponential functions are based on repeatedly multiplying by the same amount, the base. So these are really good vocabulary words and things that you should pay attention to. So I would highlight that area. Exponential functions, repeatedly multiplying by the same amount, we call that the base. The B, repeatedly adding, are the linear functions, we call that the slope. And what letter represents slope? We represent that with M. So let's talk about exercise number 1. The two tables below represent a linear function and an exponential function. Which is which? Explain how you arrive at your answer. So what we need to do is take a look at when we are trying to determine if it's linear or exponential, we go above and we see, okay, what is the difference between the two? Is my slope or my y repeatedly adding, or is it repeatedly multiplying? If it's multiplying, it's exponential. If it's adding, it's linear. So let's take a look at each table. How is it going from 5 to 10 to 20 to 40 to 80? Well, I hope that you notice that if we multiply by 2, if we're multiplying by 2 each time, therefore it's going to be exponential. Let's look at table number 2. How am I going from 8 to 11, from 11 to 14, 14 to 17, and 17 to 20? How am I doing that? I'm adding 3 each time. So because it's repeatedly adding, we are talking about a linear function. Now exercise 2 says using the same tables, find equations in standard form for each of the functions from exercise number 1. Since table number 1 is an exponential function, I'm going to just start by writing the function, or the formula, y equals a times b raised to the x power. Little refresher that my a is my y-intercept, my starting value. So I'm going to go ahead and highlight my starting value just like we were doing in class. And it's where my x is 0, so I found where my x is 0. And now that is my a. So y equals 5 times, now I don't know what's going to go in for my b raised to the x power. Sure, I know what's going to go in for my b. It's my base. It's my what is being repeatedly multiplied. So what is being repeatedly multiplied in table number 1? Well, that is my times 2. So I'm going to put 2 inside there. And b, let's recall our famous formula that we've been using all year long for linear. It's y equals mx plus b. And in the case of a linear, my b is my y-intercept. So it's to go out and find out where does my table begin. It still is where my x is 0. It's not always the first one, so you have to be careful with that. So I'm going to put that in at the end. It's going to be a positive 8. My x is part of my formula, y equals. So I need to find my m. Don't forget that my m is my slope, which is what is being repeatedly added. So in this case, what is being repeatedly added? I hope you notice that it's plus 3. Those are my two formulas that you have to memorize. Y equals a times b to the x, and y equals mx plus b. Let's skip right to exercise number 4. Recall that linear functions have a constant average rate of change, slope. That's, of course, why they have a constant amount added for every constant change in x. Let's examine the average rate of change for an increasing exponential. So in exercise number 4, we're talking about an increasing exponential function. The exponential function f of x equals 4 times 2 raised to the x power. Is shown partially in the table below. Find the average rate of change for the various intervals given. This should be relatively simple because delta means change, and x is going up by 1. This just tells me that my x is increasing by 1 each time. That's all that says. So from 0 to 1 in my x, what's happening to my y? So how is it going up from 4 to 8? That's simply all it's asking you. Well, you can easily tell that it's going up by 4. Now what it's asking you is from 1 to 2. From 1 to 2, what happened to my y? How did it go from 8 to 16? It went up by 8. That's my rate of change. And then so forth. How did it go from 16 to 32? Went up by 16. From 32 to 64, it went up by 32. E's question. What is clearly happening to the average rate of change as x gets larger? Well, you can say a couple different things here. You can say that it's multiplied by 2. You can say that it doubles. And you want to know that that word doubles means that it's multiplying by 2, because sometimes they ask it in that question. The fact that the slope of an increasing exponential is always increasing has an interesting consequence. Exercise number 5. Consider the linear function y equals 20x plus 5 and the exponential function y equals 5 times 2x. Both of these functions have a y-intercept of 5, so start in the same location. Using your calculator, sketch these two curves on the axes below for the indicated window. Label each with its equation. So what I did was I already took care of graphing these on our graphing calculator, and I took a picture so that we can utilize them. Here is my linear. So this is my y equals 20x plus 5. And here is my exponential, 5 times 2 raised to the x power. Now, in a smaller window, not taking your y's out nearly as far, which line would you take? Would you like to be on the linear or the exponential? Which one is increasing faster, and which one has a higher value in this window? Well, I hope you notice that my linear is increasing faster. So if I was over here at 1, my exponential is only at 10, but my linear is way up here at my linear is way up here at over 24. It's at 25. So clearly my linear is worth more. Now let's look at B. Again, using your calculator, sketch these two curves on the axes below for indicated window. So as I make my window larger, as you make my window larger, you're able to see exactly. So you kind of zoom out a little bit and see the bigger picture. You can see exactly that my exponential crosses my linear. So the values cross right here at 4, a little bit more than 4, 4 1/4, and a little bit above about 85. So right at 4 1/4 and 85, my linear and my exponential are exactly the same. And then all of a sudden my exponential takes off. It says, see you later, linear. So at 5, see how my linear is lower than my exponential? So as you see the bigger picture, you can tell that the exponential function may not start out as fast as a linear function, but because a linear function has a constant rate of change and never alters, and the exponential is constantly doubling in this case because it's multiplied by 2, the exponential function will eventually surpass the linear function and be worth more, whether you're talking for money or you're talking about a larger growth or decay in certain situations. Okay? Thank you and have a great evening.